Okay, I want to take a look at some of the problems that we had in class the other day, and let's solve them out. So here's a problem where I had a velocity given as a function of time, and I've asked you to start off with, when is the velocity of the particle equal to 0? So the velocity is equal to 0 when 0 is equal to 4t cubed minus 24t squared plus 39t minus 14. And so I'm just setting that equal to 0, so there's a polynomial that I set equal to 0. Now I asked you to do this using synthetic division. And so I'm going to bring back to you a couple of different things. First off, let's assume the roots are rational. The rational root theorem says take the factors of 14, that's 1, 2, 7, and 14, and divide those by the factors of 4. So the constant at the end and the coefficient of the first term. And that's 1, 2, and 4. So my possible roots are 1 over 1, 2 over 1, 7 over 1, and 14 over 1. And then 1 over 2, 2 over 2, which is 1, but I already have that. 7 over 2, and 14 over 2, which is 7, but I already have that here. And then 1 over 4, 2 over 4, but that's 1/2, and I already have that. 7 over 4, and 14 over 4. But that's 7 over 2, which I already have that. So these are all of my possible positive rational roots, and then I could take all the negatives as well. So -1, -2, -7, etc. And then I asked you to use synthetic division to see which of these worked. And I recall, and so to use synthetic division, I take the coefficients of each of the t terms. There's 4, -24, 39, and -14. Beware of a coefficient of 0. So for example, if 39t wasn't there, you still have to account for it, and I would have put a 0 in here. But the 39t is there, so we'll go ahead and work with it. And then pick a root. Just for the sake of argument, I'm going to pick 1/4. I know that won't work, but I'm going to pick it anyway. So I bring the 4 down. 1/4 times 4 is 1. -24 plus 1 is -23. -23 times 1/4 is -23/4. And then I take 39 minus 23/4, which is 156 over 4 minus 23 over 4, which is 133 over 4. Multiply that by 1/4 and I get 133 over 16. And this is not equal to 0, so 1/4 is not a root. So we'll try another one, and I'm going to go ahead and use 2. So I'd have 2 here, 4, -24, 39, and -14. Bring down the 4. 4 times 2 is 8. -24 plus 8 is -16. Add that together, I get -32. -32 plus 39 is 7. 2 times 7 is 14, and that's equal to 0. So I know that 2 is one of the roots. So my time is equal to 0 at t equal to 2 seconds. Now this has given me a new polynomial. And that new polynomial has coefficients of 4, -16, and 7. So I get 4t squared minus 16t plus 7, and that's equal to 0. And I can use the quadratic formula for this. So a, b, and c, and the quadratic formula is minus b plus or minus the square root of b squared minus 4ac all over 2a. So that's 16 plus or minus the square root of -16 squared minus 4 times 7 all over 2 times 4. So that's 16 plus or minus the square root of 256 minus 112 all over 8. So that's 16 plus or minus square root of 144 over 8, which is 16 plus or minus 12 over 8. 16 plus 12 is 28, so that's 28 over 8. 16 minus 12 is 4, so that's 4 over 8. And this would reduce to 7/2 and 1/2. So my other two times when the velocity is 0 is 7/2 of a second and 1/2 of a second. So when I go to graph that as a function of time, put time along this axis, velocity along that axis. Time is in seconds. Velocity is in meters per second. 1, 2, 3, and 4. I know there's a 0 here at 1/2, 2, and 7/2, which is 3.5. I also recall that at 1/4 of a second, this value right here is -14 plus 133 over 16. This is going to be negative. Okay, I know that this is smaller than that in absolute value, so the negative sign dominates. And that tells me that at 1/4, which is over here, this velocity is going to be negative. And as a matter of fact, if I just put t equal to 0 in here, I get -14. So I know it right here, that's at -14. And then at t is equal to 1, and I could use synthetic division for this, just to be sure I know what's happening. Bring the 1 down, I get 4, -20, -20, 19. 19 is 5, so at 1, my value is equal to 5. That's about here. Then I'm going to come back down. I don't know how high it goes, and I'm not going to worry about it until I reach 2. Then let's try 3 in here. 3 times 4 is 12, so there's -12, -36, +3, 9, -5. So at 3, I'm down to about here. And then it's going to come back up. And at 4, I'm going to be positive. So my velocity is going to shoot in that direction. So I always try a value in between my zeros to see whether or not it's positive, which it was here, or negative, which it was there. I didn't try this one, but I know it's positive there. Finally, the question asks for the average acceleration. By definition, the average acceleration is the change in velocity over the change in time. And I'm asking for the average acceleration from 0 to 2 seconds. So it's the velocity at 2 seconds minus the velocity at 0 seconds, all divided by 2 seconds minus 0 seconds. The velocity at 2 seconds was equal to 0. The velocity at 0 seconds was -14 meters per second. Got to keep your units. And then 2 seconds minus 0 is 2 seconds. Minus a minus becomes plus. I have 14 meters per second over 2 seconds, which is 7 meters per second squared, or 7 meters per second. And again, that's an average velocity, not an instantaneous velocity. So from here to here, you can see my change in velocity is positive. It goes up, and there's my change in time. So the average acceleration in there is 7 meters per second squared. Let's take a look at this problem. This one doesn't have any numbers in it, and that's what makes it more difficult. So we've got a hammer falling past our window. So let's talk about what we're given. We're given that the hammer takes a time dt to pass the window. We're given the height of our window is h, and we know the acceleration due to gravity is g. And so if I draw a picture, the hammer is falling past the window. So let's say the window is here. So the hammer falls past the window. This is a distance h. And let's assume it started up here, so it's dropped from up there. Now I haven't designated that distance yet, but it says in this part that the distance d be the distance it was above the bottom of the window. So this is d from here to here. So it's going to take a certain time to fall this distance and a longer time to fall that distance. So call this distance t1 and this distance t2. Or it might even be better to say this is some time t and this is some time t plus dt, because remember it takes a time dt. So I can say then that distance d equals 1/2 the acceleration due to gravity times t plus dt squared. Now keep in mind, t is not a given quantity. All I know is what d is. But to fall this distance right here, that's going to take a time t. But what is that distance? That's d minus h. Now I know what h is. So d minus h equals 1/2 g t squared. So again, let me reiterate. D minus h is the distance it falls to the top of the window, and that's 1/2 g times t squared. The total distance d is the time it takes to fall to the bottom of the window. That's 1/2 g t plus dt quantity squared. And what I'm being asked to do is to find that distance big D in terms of these values. Now notice t is not one of them. dt is its own variable. So t is not one of those values. So I'm interested in finding d. What I'm going to do is I'm going to solve this equation for t. So d minus h over 1/2 g is equal to t squared, or 2d minus h all over g equals t squared. And I'm going to substitute that into here. And so my distance d is equal to 1/2 g times t, which is 2d minus h over g, now that's all under the radical, plus dt squared. So there's d, but now there's a d inside of here still. So the algebra here has become quite unpleasant, but I've got to do it. So what I'm going to do is I'm going to go ahead and square this. And so I'm going to get d equals 1/2 g. Let me go to this form for starters. It's going to be t squared plus 2t dt plus dt squared. So this is equal to 1/2 g t squared, but t squared is 2 d minus h all over g, plus 2 t, which is radical, 2 d minus h all over g dt, square root terminates there, plus dt squared. So when I factor in the 1/2 g, the 1/2 g for the first one is going to be d minus h plus g radical 2 d minus h over g dt plus 1/2 g dt squared. Remember, that's all equal to d, so this is really interesting because see what happens here. Those d's are going to cancel, and that's okay. And so I'm going to get 0 equals negative h. Okay, that's this first term. Then I'm going to multiply that, and I'm going to end up with this g here and that g there. They don't cancel completely because this one's underneath the radical. But I'm going to get radical 2g d minus h. And there's a dt, and that's outside the radical, plus dt squared times 1/2 g. Now remember, I'm solving this for d, and that's great because now I've got a d right there. So I'm going to bring this term and this term to the other side. And so I'm going to get h minus 1/2 g dt squared equals the square root of 2g d minus h times dt. So I'm going to bring the dt over to the left-hand side. And I'm going to get h over dt minus g dt over 2 equals radical 2g d minus h. Then I'm going to square both sides. So I'm going to get h over dt minus g dt over 2. All of that is squared equals 2g d minus h. Divide both sides by 2g, and I'm going to get all of this over here equal to d minus h. And then I just bring the h over. And so in the end, what I'm going to get is d equals h plus this term, which is h over dt plus, minus g dt over 2. And that's all squared, all over 2g. Oh, not all. This is over 2g. And let's do a dimension check on this. H is a length, so that works out fine. H is a length, dt is a time. G up here is a length per time squared. That's the acceleration due to gravity. dt is a time. 2 has no units. Remember, I'm squaring all that. And then g is length over time squared. Right, this g right here. So I'm adding these together. So in the parentheses I have a length over time minus, those t's will cancel one of that, length over time, so that works out fine. But then I'm squaring that. So I have length plus length over time, quantity squared, divided by length over time squared. So that's length squared over time squared, divided by length over time squared. But that's length squared over time squared times time squared over length. Time squareds cancel, one length cancels, and this term turns out to just be length. And a length plus a length is a length. And so my distance d is in a length. At the very least, I know that my dimensions work correctly. So this should be a legitimate value for d in terms of the height that I know of the window, the time it takes to pass the window and the acceleration due to gravity. Not a simple relationship, but the relationship that I'm looking for. You go ahead and just address this for a moment. This problem is really not too hard. The main thing that you have to do with this problem is this part right here. The speeder passes you and it takes 2 seconds before you get moving. So you have a constant acceleration. The speeder has constant velocity. So the principles are constant acceleration and constant velocity. Now when I look at the position of the speeder, x of the speeder is equal to 45 meters per second t. But we have to keep in mind he's been traveling 2 seconds. So what I want to do is I want to set t equal to 0 when the patrolman moves. And if I do that, then the speeder already has a distance of 90 meters, 45 meters per second times 2 seconds. So the patrolman starts moving, the speeder is already at 90 meters. Then the position of the patrolman is 1/2 5 meters per second squared t squared. No initial velocity, no initial position, because I'm setting the origin at the sign. So where do I catch the speeder? That's position. And I catch the speeder when the position of the speeder equals the position of the patrolman. And so 45 meters per second t plus 90 meters equals 1/2 5 meters per second squared t squared. You set these two equal to each other, solve for t. What does t equal? And once you've got that, you substitute that back into this equation or this equation. They should give you the exact same value. How fast are you moving? Well, you know what your time is. My velocity is equal to 5 meters per second squared t plus my initial velocity, which is 0. So take that t and you substitute it in there. That's the velocity of the patrolman. The velocity of the speeder is 45 meters per second. That doesn't change. Then in the second part, I tell you, well, I have a maximum value for my velocity of 60 meters per second. And so what that says is that x of the patrolman is 1/2 5 meters per second squared t, but to a certain maximum. What's that maximum? Well, the velocity of the patrolman is 0, my initial velocity, plus 5 meters per second squared t. And this maxes at 60 meters per second. So what I need to do is I need to solve this for t. And when I do, I get t is equal to 12 seconds. Okay, 60 meters per second divided by 5 meters per second squared. And then I have to say, well, where am I? And how fast am I moving? Well, of course, I'm moving at 60 meters per second. But my position at 12 seconds is equal to 5 meters per second squared times 1/2 times 12 seconds squared. So that's where I am. At that point, I have a constant velocity, and so does the speeder. So my position is, well, I need to figure out where I'm at. And that's going to be right here. That's where I am. So I'm just going to call that xp initial plus 60 meters per second times t. The speeder is at 45 meters per second times 14 seconds. Remember, he's been traveling for 2 seconds. Plus the 12 seconds I get right here before I reach my max speed, plus 45 meters per second t. So this t is 12 seconds after I start. So I've got to keep that in mind. So when I solve for that t, I've got to add 12 more seconds to figure out where I am at. I'll let you solve that problem from there.